Okay, so for the final projects for VR class, we have made a mobile game called DT Tower Defense, and uh, this is made by me, T, and my teammate Du Fang. So Tower Defense is a kind of strategy video game, and the goal of this game is to defend a player territories and possession from the enemies, and it's usually achieved by placing defensive structures on along their path of attack. And in this game, user can render the game environments into real world using a phone camera and interact directly between the user phone and the game environment to raycast technology. And then user also can make strategic objects placement and movement decisions.
Cool. So about the stack that we use, instead of using Vuforia, we use AR Foundation, which is almost similar to Vuforia. The difference is that it isn't a marker-based AR framework, but it tries to simulate the world in the game scene into the actual real world. So whenever you open up an AR screen inside your game, it will, wherever you point a camera or your phone to, will be the position of the camera inside your game scene. And it supports a lot of things like cross-platform, motion tracking, environmental understanding, and the light estimation.
While developing this game, we have run into some problem like the game is running stable on Xperia 1 with the highest FPS, but sometimes it lags on the Redmi Note 8. And sometimes the game environments and the objects in the AR have some glitches with their locations, but I think this is just a common disadvantage of AR and still haven't got any solution yet.
Okay, so time for a live demo. Let's pray that the God of the live demo will like this, okay? Cool. Let me bring, okay. Can you guys see the phone mirror screen?
Yes.
Okay, yeah. So I actually turn on the tab option and the mouse, the tracking. So this doesn't belong to the demo, just for you guys to know. Okay. All right, so this is a start screen. When I press the start, it will start the first scene where I can choose where I want to place the game environment. So as you can see, as I move my camera around, I already attached a script so that this placement object will move around wherever I cast my ray from the camera. So wherever I choose, I just click yes, and it will move to the next scene. So it's a tower defense. That means I can just place object. I can just place object on my scene and just play it like a normal game. I can actually shoot it. And summon stuff, just like a normal game. So our goal is to expand this, and then maybe later on, we'll try to utilize the environment, environments surrounding the player to actually make them make some strategy decision. But for now, this is just a proof of concept. So let's see if the enemy can actually defeat us if I don't do anything. Okay, they cannot defeat us, but however, so that's a game. So as you can see, whenever I move around, the object doesn't move at all. That's the power of AR Foundation. And I think that should be it for the live demo. And that should be it. Do you guys have any question at all?
So what was the framework? You said you didn't use Vuforia. What was the name of the framework you used?
AR Foundation.
AR Foundation. Okay.
Yeah. So it is made inside Unity too, and is
Uh,
one of the AR package which come with Unity.
okay. Okay, this was also a great AR app that was created by Duke and Ty. This was excellent as well. Many thanks. Any questions from the presenters?
Yeah, I'd like to ask Duke how and T as well. How did you guys feel about working with Unity throughout this whole thing as far as a software stack? How did it stack up with other stacks you've used in the past?
It's actually, well, I actually have experience before, so I kind of used all the new incentive costs, but it was very hard to some extent because you need to configure a lot and you don't have like control over all the native stuff. And especially with the AR Foundation, we rely totally on the SDK, the AR Foundation SDK to work. And if something happened, there is not a lot of resources out there yet because it's kind of still new and it's just, I think, only 1 year old, something like that. And yeah, that should be the problem. But other than, and one other issue is that the Unity, the Unity answer over here, link, usually contain very outdated answer, which usually belong to 2 or 3 years ago and is not updated with the latest version of Unity. I'm not sure why, but that's usually what we found when we search for answers.
Yeah, that's been roughly my experience as well, and so I was curious as to whether or not it was just me having terrible luck or other people. It's interesting to kind of see people working through some of those issues. Thank you.
Oh, yeah, cool.
So yeah, my name's John, and I also did a phone VR project. Before this class, I had never actually not only worked with VR, but never had even experienced VR before. So it was a really fun experience because of that. I guess the first thing I did when I started this class was do a little research, and I bought one of these cheap Walmart phone VR headsets, and it was just before Halloween, so I looked for some apps to kind of explore what was out there and found that, despite the hardware limitations, that, there were some haunted house games that were surprisingly fun, and I found that just VR could be really immersive, even limited to a phone, and so I wanted to go kind of a horror scare genre was the style of my game.
So John, what is the price of the headset, this thing that you purchased? And also, what is your phone? Like, is it old and you were still able to run?
Yeah, so I have I think this is a Galaxy S8, Samsung Galaxy S8. And so I think it's a few generations old, but not crazy old. But it was enough that I'm kind of glad I had to deal with some limitations. I've never had to deal with hardware limitations before using Unity, so I felt like I learned a lot about that because of that. But this was just, I think I got this at Walmart for like $15 or $20, and it's just a real basic phone VR headset. No bells and whistles, it's just the lens. Okay, well here I'll start my demo then, I guess. I start with this little blurb here. Just to kind of set the scene. It's kind of a monster escape avoidance game. So the first thing I had to decide was sampling these other games, how I wanted to move around, and only having the 3 degrees of freedom of a phone VR, movement was a huge consideration, and I decided on this target-based movement style, and it lent itself to exploration really well, but wasn't so great for fast-paced gaming. So I had to find a way to make it more slow-paced when I was developing the game. And so I wanted to have a lot of like safe scenarios. So I'll pause right here. So this is your first kind of introduction to the monsters. So I wanted to do it in a way that the player doesn't feel panic or frustration. My family and friends that demoed it, that was on an early iteration, something that I had to they got frustrated with was the lack of the lack of control with only look where you move. And so one way to do that was just keep things really simple and slow, and automate as much as I could. So the crouching here in the grass is just automated. If you walk in a certain area, it automatically crouches. And so you get introduced to the enemy, and you can kind of watch him, but from the safety of the tall grass. You wait for him to go, and you can run across. Another thing I found when I was playing some of these other games, when I was deciding how I wanted to make my game, was with VR, to make it immersive, sometimes instead of putting things right in their face, you need to let them see it themselves. So I don't think we're getting any audio, but right there I had this sound cue, this loud clanking of monsters' feet on the container that I found my friends would get spooked by looking up, because they weren't looking up there originally. And so that was something I kind of relied on. I guess moving forward, talking about that lack of control and the in-your-face kind of aspect of the VR, I wanted to really utilize that. And so I had this forced interaction right here with the monster, and it really serves two purposes with this goofy punch. I wanted to show the player they should incentivize stealth to try to avoid the monster, but also to reduce that panic of the gameplay and the limited mobility. That, look, it's not the end of the world. I have this goofy punch sequence, and the monster goes down, and you have 15 seconds to get away, and that helped slow the gameplay down, but still kind of have that in your face feel. You can see I'm trying to keep it puzzle based as well. I had the little plank you had to walk across, and now this little box sequence where you have to push the box to get through here. And so I guess, like I said, I hadn't really used VR before. And I haven't had the limitations of mobile before, but I had used Unity. But that required me to learn a lot about optimizing my scenes when making like a mobile game. And so one of the biggest things that helped me speed up the frame rate and reduce the calculations was baking light maps, which I didn't really know much about, but it was super helpful. So my game obviously is the most beautiful thing to look at, and that's because it's not rendering a lot of this stuff in real time with real-time light sources, but it allowed me to have lots of scripts running for the different enemies and objects. Also, you can see there's a lot of boxes I have. Reducing triangles really helped speed up the gameplay. I originally wanted to have this be like an open world game, and I loaded it onto the phone, and it would not play at all. So reducing the area to reduce the draws and stuff of different objects really helped the gameplay. And then going back to, like I keep talking about these, for me this was all about hardware and gameplay restrictions. So going back to the player dealing with these input restrictions, I guess, I wanted to make as much leeway as possible for them. So another thing I did was the monsters, he actually caught a quick glimpse of me as I was going around that corner, but he didn't quite attack right away. So I had a kind of a timer for him to see you and recognize you. And then by this point, I've kind of established a routine of gameplay. And so for this last little zone, I wanted to really keep up the puzzle and the interactivity of the game. You've been running from these monsters the whole time, so I wanted to finally allow the user to get a kill one. I guess you probably can't hear, but there's hopefully a pretty satisfying crunch there. But I wanted to keep it puzzly, so I didn't want to give it to you. So the second one, he doesn't get lured in, so you got to go down and trick him into it. And the switch up there for the control was actually something I had to iterate on quite a bit. I didn't want to like spell it out for the player, but when I had friends and family test it, without any kind of controller, at first they were like, what do I do here? The red color of it was an obvious enough indicator to them that it was interactive, but they didn't know what to do. So I added that blue shade, and that really helped them identify when it turned blue, it's activated something that's maybe I'm gripping it, now swipe and it'll move, and that helped them a lot. And then, finally you killed a couple monsters, and I have this kind of ending sequence. Mine's also kind of a proof of concept, so it's the graphics obviously aren't very polished, and also it's a pretty short game, but you get this last sequence here. Maybe there'll be another chapter where you get to pick up a weapon and actually fight one of them. So I guess the key takeaways for me were, as I said, just simplicity and from a hardware perspective to make it run quickly. And also from a gameplay perspective, I think VR is really exciting, but for me included, it's really new. And a lot of friends and family that tested it, they had never experienced VR before. So making it accessible to them and not overwhelming them, it's really in your face. So keeping it simple from both those perspectives was key, and having old experiences be predictable once a game mechanic has been established, but then also introducing new but intuitive experiences where they're challenged, something that requires them to think, but it's something that's still obtainable and something they can figure out to get that novel feel, but also rewarding when they do figure it out without getting too frustrated. And I think despite Google VR kind of being old and phone VR fading out, I think it still taught me a lot of these important concepts and considerations of VR as a whole. And so it was a really fun experience overall. Looks like, sorry, I've been talking real quick here, but I haven't been able to read the chat, so I'm going to stop sharing if anyone has any questions.
So this was very, very good. This was excellent. Thanks a lot. And you did a lot of, I think you learned a lot as well. So I think people have some questions about the mobility and movement. How did you solve that?
Yeah, so it is 3 degrees of freedom. And so everything is just look-based. So anytime you move or interact, you have to look to do it, which, as I was saying, really slowed things down. And could be frustrating when I had early iterations of it, just because when you get in situations where you need to move quickly or the monster's coming at you, you can get frustrated and panic. So a lot of the things I talked about were in hopes of slowing the gameplay down and making it not too intense. Thank you, Sam. Yeah, I watched, like I said, I played a bunch of games to kind of come up with the target system. I played one where it just always walks forward, and I found myself walking into walls all the time. And so I wanted to try something different, and so it seemed to work for me. And Google VR it has some built-in functions. The gaze, it's pretty much one, as far as the VR functionality is concerned, it's pretty much just one function. And I just expanded off that of just certain objects trigger certain things. And for me, I just had targets that trigger a movement function.
Excellent. Very cool movement idea. Okay, any questions from John?
I have a question for John.
Yeah.
First, I just want to say that was an awesome demo. And it sounds like you put in a lot of work into optimization. Do you have like a rough estimate of how fast it was going before you optimized it and then how fast you got it afterwards?
So I had to optimize as I went a lot. As I said, the first iteration was going to be an open world game, and I had really, really far draw distances, or just, of viewpoint, whatever. And the game wouldn't run at all. So I would try things and then optimize, try things and optimize. But yeah, I think a lot of the stuff, it worked with real-time lighting after I created a lot of static objects and reduced the gameplay areas size. But it kind of was choppy and jittery, and with my phone at least, it wasn't playable or fun. But after I created a lot of static objects and did all that light map baking, it got it. That was the big thing that made it playable.
Right on. Thank you.
Yeah, if that answered your question.
Hello. So my name is Alyssa, and my partner here.
Hi, I'm Alejandro Castañeda.
And we created Viber VR, which is a virtual experience for music enthusiasts. And on my screen, it's not changing slides. There it is. Okay. And our project motivation. So rather than making a game, we wanted to build an experience. And we've been missing going to concerts the most since the pandemic hit. And social distancing means no live shows. Alejandro and I also share the love of curating music playlists and sharing them with our friends, and we wanted to integrate that hobby into our project. We were also really excited about the potential use cases of our product post-COVID, and Alejandro will talk more about that in later slides. But ultimately, we were inspired by Porter Robinson's Secret Sky Virtual Festival that took place just after the quarantine in spring. And what it is, it's a web-based AR experience. Here's a video to the left where attendees all over the world got to interact with live music. And so these colorful squiggly lines you see here, you got to control one of them, and all the other squiggly lines you see there are other people around the world who are listening to the same music. Yeah, it was a really cool experience. And next, Alejandro will talk about project use cases.
The idea behind our project is really to help expand the entertainment industry. By having this sort of product, it would help to enhance the life of a club, a lounge, or a festival, and really provide a unique AR experience that everyone attending can participate in, where they have a form of music going on and they have this sort of art all over around them that helps to like really enhance that experience. So the idea behind this too is that people will be able to go to the same lounge, but everyone can have like a different sort of goal or like aesthetic behind them, and they'll find whatever experiences they're looking for. So you can have someone listening to like punk rock while someone else is listening to rap, while someone else is listening to jazz. And everyone can share the same space together post-COVID. This also helps with artist-curated experiences. So artists at the moment, they have like visual albums like Beyonce's Lemonade and Frank Ocean's Endless, where they create sort of like a visual storyline to the music. So you can listen to the music and you also have like another sort of like experience that they made for you through the album, the music videos. But this would help to create even more of those where now you have a virtual experience and people can interact and indulge in that environment. And they could put their music, they could put other skills, and actually elevate their users to another level of like an experience with the album. Lastly, this would help with just escaping. With many of us finding music as a great way to escape already, then why not use VR as well? And it would really just help to like tune out and actually have like all of your sensors deprived into this whole like VR experience, which could also be used for music therapy or other sort of simulating therapies that exist out there. Next, Alyssa will talk about how we did this, or what we did.
What and how. So we created a virtual music listening experience, and we did it all in Unity and Blender. In Unity, we created 2 scenes, and we will talk about that later. And we also utilized Unity's camera and lighting. And in Blender, we created more complicated models and imported that into our Unity project. Our project is meant to be used with Oculus, so the user can click a button and be transported to these different scenes that we've created, and they are free to explore the spaces while they're listening to the music. We collaborated and we collaborated remotely via GitHub, and there's a link to our repo for anyone interested. And about the scenes, we'll talk about our 2 scenes, which is called the home scene and the green scene. Alejandro will talk about home scene.
So the home scene comes sort of as an intent to be like a landing stage for people to start with. This is really the first thing that they'll see as they start the program, and hopefully it's something where they can learn like the controls and kind of get a little like sense for what the environment will look like. This actually came from inspiration from Glass Animals Dreamland, which was an album that came out this year. And the whole album art in Spotify Canvas uses these really like neutral, pastel-y, like virtual, almost like vaporwave style like space to it. And so we wanted to like test our skills, kind of recreate something like that, and also throw in a little bit of neon for fun and just like test emissions and whatnot. And the music features Healing by Computer Data, which is a nice rhythmic house beat to start off the journey. So we'll play a little bit of the scene here.
Music's not coming out on my end. I'm not sure if anyone else is hearing music.
No, it's not coming.
Yeah, Zoom screen sharing has issues there.
No. I think if you are using a headphone, Alejandro, if you turn it off, I suspect the video music will come out. Let's start it.
Okay. Can you hear it?
There it is. Yeah.
Just turn on the volume. I mean, make it louder.
I'm trying, and that's the loudest it'll
Yeah,
go.
it's good. It's good. Good.
And yeah. So we just kind of threw in a little bit of Bart Simpson, a lot of like palm trees and other things like that. And next, Alyssa will talk about the green scene.
And so before we play the video for the green screen, I'll talk a little bit about it. I was inspired by nature for the green scene. My favorite memory before quarantine was going to the Herbie Hancock and Kamasi Washington show at the Oregon Zoo's outdoor amphitheater last summer. And so I just very much enjoy listening to jazz outdoors, and I'm just naturally drawn to mountainous landscapes. So I wanted to recreate that experience here. So with the green scene, I got experience with painting the terrains, painting trees and shrubs and rocks, while also this like first person controller person. He's pretty cute. Yeah, so go ahead, press play. Sound's not coming through again. Well, there would be Thundercat playing in the background. Okay.
Is that good?
Yeah, the sound was coming through.
Let me pause it. There we go. All right. Sorry, I didn't realize that I was muted for that, and it hit later on. All right. So a few things we learned from this. First of all, Unity is actually pretty hard and complex. There's a bunch of layers that we had to learn for each element of this, and each one kind of brought its own can of worms. So emissions, lighting, solid interactions between what the player and the program can do were difficult. Something that we created on Blender, we would import into Unity, and it was completely different than what it would look like, just because emissions and lighting and the shaders don't actually like transport over from Blender into Unity. But we did get a great grasp of what we can do, and we're especially proud of our first program for what it can make. Additionally, 3D creation and Unity just makes it a lot better. We tried using a lot of like assets and packages, and we did for a good amount of things, but also Blender has a lot of capability that we can actually create complicated models to what we want it to look like, and we can import that into Unity. So we mainly used Unity for the scenes, putting them together, like all the lighting and the interactive gamey elements to it. But just like kind of like looking at that image on the side, that's like a crazy amount of work behind it, and it really grew our appreciation for people that can make these like really complex things behind it. Lastly, just don't trust every asset downloaded. Most of our assets were actually pretty useful, but there were quite a few that never really delivered on what they were promising, or they would just add complexity to the project, and it would take like a few steps to retrace back to a stage before that.
Yeah, and here are some things that we'd like to accomplish had we had more time for the project. We'd like to add more scenes. I'd like to add a jazz club scene that features standards in modern jazz, or a house party scene featuring 90s hip hop, and even an electronic scene featuring out of this world experiences where we could get like really creative with, you know, the elements that we put inside of this world. We'd also want to make the playlist interactive. In both of those recordings, we've only had one song in there, although there was a playlist asset that will randomly select a song, but we would like a user to be able to flip through this curated playlist and select what song they want to listen to. And we also want to combine the scenes into a single universe. So to make it easier to collaborate remotely, we split the scenes up. So Alejandro worked on home scene, I worked on green scene, and we would like to combine them into a single universe. And here on the right, you see these 3D objects. That's how we envision an Oculus user would be able to select which scene that they'd be transported to. And then lastly, we'd like to connect to streaming services. So we could create these playlists on Spotify, YouTube, and Tidal, and then we can import them into the project. And so the user could use the interactive playlist that way. And yeah, that's it.
Thank you.
Thank you, everyone.
Thank you. This was also excellent. Thanks a lot. Very good job. Yeah, I mean, mixing VR and music is definitely. Is anyone working on it? Alyssa, did you see any startups, any companies working on it? Like startups.
I've seen like individual artists who use this as part of their own work. Like earlier, I mentioned Porter Robinson, but yeah, actually, then he had to contract a company to do that for him. I just don't know it at the top of my head. So yes, there are companies out there that will work with creatives to bring this vision alive. So.
And we work on the Oculus Quest 2 to make the VR virtual world. And we make a game that is Crazy Kitchen. And first, we implement the locomotion from the Oculus integration that we use the teleportation. And we also build a customer hand that works from the Oculus integration also, but we can build different materials like different color, and even we can use the cubes, spheres, and some the other game objects to instead to use the customer hand. And we also use the random instantiate cubes on the ground, and we just build 3 cube prefabs this time that will instantiate in the with the random prefab and random place, but with limitation. And I will show the first part. And right now I just log into the game into the Oculus. And we can in the VR game we can look around, and here the blue to they are the customer hands, and the Oculus controller can automatically to check your hands movement. Here is our teleportation, and the green one is the ray, and we use the ray to check out where the player wants to go. Yes, and we can see on the ground there is some cubes. The green one is just randomly instantiate on this place. And second, we also implement the grabbing objects and to check out the occlusion and with the dynamic text. And the grab others is also from the Oculus integration. That's when like a list of things, grab objects can be grabbed, and they can be set up to be it can be grabbed or not. And the occlusion method is from the Unity. The Unity already support you the function to check out if the occlusion enter or not. And we just said if the cube's name contains the special characters, we can add 1 materials. And in the dynamic text, the text mesh in the Unity can display the variable value, and we can check that. Okay. And we can just grab a blue one cube. And we can see the blue cube, if touch the floor of the, it will add one material. And we can try to grab two green one cube right now. And plus 2. And 2 of the red cube. Okay. And then we also implement the UI for the interaction. We use the canvas image and 3D text and buttons. And in the it will support the event helper by the Unity default, but we use the UI helper from the Oculus that is also from the Oculus integration. And by using the Oculus, we have the retransform from the right hand to check out if the user want to make the operation. And the canvas is one method to create the UI in the Unity. And the 3D text one is the same as the demo 2 we just said. It will tell user how much material, the material is enough or not. And the 3D text 2 will tell user how many items has been combined. And the button is to make the operation to decide which items will be created with the condition. And we can see there is the recast. And if we just press the button, it will create the cubes. And we can see the numbers has been minus. And we can just create something else. And right now there is 0 seafood, 0 meat. And if we want to create something new, there will show no material. And finally, we also implement the score, time, and destroy items. And it will we will randomly to create the game objects of 3 prefabs of the to check out which combined foods we want. And it will display the lifetime of the prefab. And when we finished, when time finished, it will destroy the prefabs. And the score of achieve the requirements of the robot depends on how many times left by the robots. And when conclusion happens, the robot will check out the items. And we can see the last demo. And we make one conclusion and it fix the condition, so that will get the score. And there is another example to show if we use the material cubes to implement the conclusion, we can see the cubes has been destroyed because it has been used. And for the summary, we still have some bugs to wait to fix because sometimes the conclusion will count twice. And this one is easy to fix, just get the lifetime to be 0. And when the collusion happened, we directly destroy the items. And also something like the we can the movement will. Oh, sorry. Okay. And our future plan is we can add a backup system. It will save all items, and the UI seems like more faster than display all game objects on the ground. And also the difficulty selection, because currently most of the variables are still constants, so that we don't want. And we can add some others to make the game become beautiful. And we can add more material cubes and combine the cubes. And there is the link of our full video and PowerPoint. And that's all. And here is our full video to show like what's the process. But it's really too long, and we can see the size is 850 MB, so it's too large. And that's all.
So I'm Brandon.
And I'm Logan.
And our project is a space simulator. So the equipment we used for the project was using the Steam VR plugin, and then using the HTC Vive. Most of our work was using the standing only mode, so it creates it similar to 3 Degrees of Freedom, just so that there's no issue with room scale. Next. So our motivations for making a space simulator was because I think at the beginning of the term, Star Wars Squadrons came out, and there was a VR implementation for it. And so it made fighter and flight simulator games much more immersive. And then our goal for making it was to help with the space constraint that some people might have with room scale VR. And since the player is sitting in a cockpit, they're basically using standing mode only, and then they can just sit in a chair. And since the player is driving, motion sickness is alleviated a little bit as their body isn't moving without them. Next. And so what makes a good spaceship simulator? So it's mostly realistic ship controls. So controls that make sense to user expectations. So it's not going to be like a normal flight simulator. There's not much gravity. And the 2 core questions we needed to answer were, how does it move? Can it strafe, go left and right, forwards and back, up and down? Can it roll? And also, how fast it should move. So we don't want it to move too fast and actually cause some sickness in the process. And the way we dealt with controls is using HOTAS, which is in the image to the right, where it's hands on throttle and stick. So there's a throttle control, and then there's a stick control to control the spaceship itself. So next.
So one of the issues with HOTAS is HOTAS can be quite expensive, and not everybody has the budget to purchase a controller. So our idea to solve this was to implement HOTAS within the game itself. And so we have a virtual joystick and a virtual thruster in the game. And this is the control scheme we came up with, and unfortunately it didn't quite pan out like this. Our controls are very simple. It's basically just a joystick to tilt the ship, and then a thruster to go forward and back, and then we have the blaster. So I'm going to go ahead and start the gameplay portion. If you can't hear it, just tell me and I will talk over the video instead. Hello, welcome to the gameplay portion of our presentation. Just double checking, can everybody hear the audio?
Yes.
Okay. For this portion, I'll be playing the game and going through and showing you the controls, and just flying around, destroying a couple objects, and that's pretty much it. I'll explain some problems we had developing certain features as we go through. So I'm going to go ahead and play. Put on the headset. So you can see that I am in VR, and this is the ship. This is the virtual joystick, so if I push it down, the ship moves down, up, left, right, And this is the thruster. So this is a dead zone. I made a dead zone because otherwise you'd have to be like super precise because the speed slowly increases the further you push it back or forward out of the dead zone. And then you can also, if you want to not worry about it and you just want to keep going, you can put it in whatever position you want and then let go of it and you'll keep going. The joystick, so you just push it forward, back, left, right, you'll move. And then if you pull the triggers, it's a little fast and needs to be tuned a bit. You'll shoot a gun and you can destroy these objects. So I can get going a little slow here and move and shoot these objects. So some problems we had while developing this is the joystick. It uses Euler angles to figure out which direction it's tilting. And the problem is the way it's set up is we would need to use local Euler angles in conjunction to the ship. But this needs to be parented to this, so we can't use the local Euler angles because this whole thing is rotating. So the way we got around that is we made a fake object that copies the rotation of this top part that's parented to the ship. So we check that object's Euler angles in order to determine which direction to turn. The thruster was pretty simple. It just follows sorry, my controller's freaking out. It just follows the user's hand. And when it's past this portion of the dead zone, it uses its position to determine how fast it's going. So 0, it uses the X position, so the local X position. So this would be X equals 0. And this would be, and then reverse starts at X equals negative 0.1. But we adjust the value so that we don't end up going too fast as soon as we hit the reverse. And then beginning starts at 0 all the way up to 2. So you can go pretty fast here. And that's pretty much the game in its current state. Thank you. So again, some of our major challenges, most of them stemmed from just not knowing Unity very well. I had a little experience with it, but not too much. And most of my experience was in creating 2D games and not 3D games. So making a 3D game for the first time as well as a VR one was quite a bit of a challenge. Top of that, learning the Steam VR toolkit and exploring the assets that Unity and Steam VR have to offer. So some things we can improve on is we can improve on better physics accuracy, gameplay mechanics, AI. We can add objectives, multiplayer. The user experience can be a little bit more fleshed out. And the same thing with the HOTAS controls. They're a little janky. That could be improved by adding, by adjusting the dead zone on the joystick and to make it harder to accidentally turn and adjusting the speed at which you turn a lot better. So these are some references we had, and any questions?
Okay, this was also another excellent presentation.
So one of the biggest problems that we ran into right off the bat was the fact that Andrew's using an Oculus Quest. I think V2, right?
Yeah, it's a Quest 2.
Yeah. And I'm running a Vive. So right off the bat, we found that because of some kind of political issues with with Valve and Oculus, they, in the most current versions of Unity and the most current XR plugins, just flat don't work for crossplay. So we actually had to fall back to an older version and using the SteamVR, OpenVR implementation. But that allowed us to use the SteamVR interaction system, which we used pretty heavily. So what we did is we built a just kind of an archery range and made some little mini games in it. And I have a video to show you that Andrew took earlier, and then I'll show you mine after that. So Andrew, it's all yours.
All right. So this is just me putting on the headset when I started recording. So yeah, Bradley set up the bow mechanics. So this is just me showing the mechanics of the bow, that you can pick it up. And he also created this scoreboard and this new game here where you can increase the time for a game, and you get a score by hitting the target in a certain amount of time. And I made that laser. So initially you could press the buttons with your actual hands, but because I had to use, I'll go into it later, I had to use actually Oculus Link to get this to work. I couldn't actually run it on my headset directly. And because of that, I didn't have the proper cable. I had to use like a very short cable. I couldn't really move far from my computer, so I had to implement some locomotion and use that laser to press buttons. Yeah, surprisingly, the Oculus worked pretty well using SteamVR, despite the issues we had earlier. And I'm not very good at hitting this target 40 meters.
The bow physics actually turned out to be kind of a fun project too, because I did some research on like how far should the arrow fly, you know, how much force should I put behind it, and after researching for a bit, I found out that it was just a linear, you know, just straight up the distance that you pull it back is how much power it gives. So it ended up being a lot simpler than I thought it would be.
Yeah, and here I implemented locomotion just using a little circle that shows you move the joystick around, it'll show you the circle where you're going to go, as opposed to smooth movement, which kind of made me feel motion sick. So just using the teleportation circle, I think, worked better. Yeah, so I had a button on the controller that toggled the laser, so if you didn't want to use the laser to interact with the UI, you don't have to use it. And actually, SteamVR's input system with controllers is actually really nice. It abstracts it away from the controllers where you just make actions. And in the code itself, you just use the actions and you later assign actions to buttons depending on the headset you're using. So I think it's better than Oculus's implementation of input.
Okay, so that's the end of yours. I'm going to pull up mine real quick. Okay, so this video is just kind of more showing how the little minigame system works and how the bow actually functions. Basically, the bow has two interaction points on it, and one of them is to hold the bow and the other is to grab the string. And I decided to, first off, not put physics on the bow just because it's a pain to have to pick it up every time. But also just spawns an arrow when you grab the string, again, just for convenience sake for this. But yeah, I programmed a little target to react to hits, and it keeps score. And in a second here, it should be showing. Yeah. Andrew mentioned earlier you can also push these buttons. That's kind of because we actually, because of the cross-compatibility issues we kind of had to develop a lot of these separately and then bring them together at kind of the last minute. So I guess you can either push those with your hand or use a laser pointer for them. But here I'm just trying to put as many into the target as I can and show the high score function working. I don't think I actually got a new high score with this though. Yeah, so I think that's about it. I won't make you sit through the rest of this because it's kind of more the same. But yeah, any questions?
Any questions?
Yeah, I had a question. How did you guys go about, I guess, collaborating your code? Did you use GitHub or?
We used Unity Collab, which
okay.
turned out to be kind of more of a pain than it was worth. But
yeah, I noticed that their servers would drop a lot. So then
we also had a weird issue with project settings not being pushed with Collab, and we had some brokenness from that too.
Really, every time I try to pull an update, I just wanted to overwrite everything I've done instead of combining them. So I'd have to write a backup and then remerge everything every time I'd have to combine this code. It was kind of annoying.
Yeah, I had previously been avoiding Collab just because I knew that it was garbage. And I was hoping that it was better, but it really wasn't. So do not recommend.
Not so much a question, but you'll be happy to know that eventually the political head clashing between Valve and Facebook is hopefully going to come to an end in the next year or two. OpenXR is making a lot of progress.
That's what I've heard. But as of right now,
yeah, no, as of right now, yeah, Unity does not have OpenXR support. They promised it by sometime at the end of 2020. Well, we're at the end of 2020, and well, you know, it's been a miserable year. So
yeah, I couldn't get SteamVR to run on because my Quest actually has Android, and I couldn't even run SteamVR on it natively because Steam wouldn't make Android. Because
are you using? Oh, sorry.
So originally, I was trying to run it natively on the Quest, but because it has Android, SteamVR won't compile whatsoever. It just says it can't down. I had to use Oculus Link to basically run it on my screen and stream it to my headset and treat it like an Oculus Rift.
Oh, are you using like OpenOVR or something, or are you just like directly streaming it?
Oculus has their own. It's just called the Oculus app. You download it on your computer, and then when you plug in your headset, and it just detects automatically. I'm not entirely sure how to do it.
I have a question for you.
Well, that's definitely a good workaround.
So last question by John.
How did you guys go about making all those really beautiful assets?
Oh, yeah, I forgot to mention. Those, I can't take credit for those. Those are things that I had left over from another project I did years ago.
Okay, cool.
This is, the terrain is just, it's just the terrain tool. And then the trees are all, actually you can look in here. Assuming you can still see this, all these trees are using the tree tool for the terrain. So.
Okay, so my name is KT.
Hi, and I'm Adam.
And we did a Mars-themed VR game. There we go. So we had a couple goals for our project when we set out. We were less planning to make like a structured game with like an end goal, more so just like creating a visually interesting virtual reality environment and having like a exciting otherworldly experience for the user. We wanted to add some assets to enhance the overall appearance of our game, and we wanted to implement some kind of locomotion, either like moving around or being able to like jump or fly, as well as controller and hand tracking so we could pick up and grab objects and interact with the scene, and just in general learn about VR and Unity. We had a lot of problems setting up Unity. We started off by downloading similar Unity versions, just like within 0.02 of each other, and did the regular stuff like creating an Oculus developer account, had to enable developer mode on the headset. We imported the Oculus SDK, but we both found out that we needed to download Android Studio because the Android SDK in Unity didn't work for either of us, so we had to point it at the path for Android Studio's SDK. We had a lot of problems with configuration as well. So for Atom, the Unity and build and run, the Unity's build and run feature didn't work for the Quest on Windows. So he had to build with the Oculus plugin. Rather than using the Unity collaboration, we tried to use GitHub. So there's a template there that you can use that has like a gitignore file for Unity specifically. And that helped a lot. I'd worked on Unity for an AR app in a previous class and discovered that there were a lot of problems with merge conflicts. So we took turns working on the project so we didn't have to deal with those as much. We discovered pretty late in the project that using different versions at all was a big mistake because all the upgrading and downgrading to work, like to pull it down and check each other's stuff and add to it ended up breaking our original project. So the final version we settled on just using the one version that worked for one of us. So one person could test it, but I was never able to get it, the final version, to actually like deploy on my headset. I think some other issues may have stemmed from were on Mac and Windows machines, so that's definitely something to be aware of, and Oculus Quest versus Oculus Quest 2. And the biggest issue I had was that the Quest 2 wasn't recognized on older versions of Unity. So for our terrain, it's modeled after Mars. The first project, we tried to do it ourselves. We put a couple of mountains in, and sometimes there were issues with rendering when the user would try to turn their head. The mountain wouldn't fully render, so we minimized that by scaling down the size of the environment and the height of the terrain, as we learned in class. Making things flatter and taking complexity out of the shapes helps a ton with performance. And for the new project, we just ended up using an imported asset that was really easy to work with and had a really cool final result.
Okay, so for locomotion, we just started out with the OVR control scheme, which just kind of uses the left-hand joystick to move around, and you can use the right-hand joystick to snap your orientation a certain way, so you don't have to physically reorient yourself. And this works just fine for just walking around, and obviously we had a camera rig set up and a tracker so it would follow our head movements, all 6 degrees of freedom. But I also wanted to implement a jetpack because we were in space, it's space themed, and there are some like hills that you can't just walk up due to the gravity in the physics engine. And also I played a game called Echo VR. If any of you guys have played it, you basically control a robot in space, and it made locomotion feel really immersive and believable because you didn't really need to use your legs that much. You could just kind of jet around. And I basically adapted somebody's script I found online. He did a tutorial on creating a jetpack in Unity, and I tweaked some things, and it worked great. At one point, we did end up trying to track hands, and that works great with the Oculus software. Yeah. And this is a demo of all the things we implemented.
Can you guys still see that okay?
Screen is black right now.
Oh yeah, that's fine. It just takes a second.
So I'm just displaying the typical locomotion. I have the hands that are attached to the controllers. I'm kind of snapping around a few times. Here I display the laser gun. You can pick it up and grab it and aim it. It shoots a beam that can reflect off surfaces. We have an alien that we asset that we imported. Beam goes straight through him. We didn't get to damage him just yet. The cubes are reflective. Material just look kind of space themed, and so it would bounce things off of it. And you can multitask. You can use the jetpack and move around in the air with the gun in your hand and firing it. And that's really what I had envisioned for this project, was just a really immersive VR experience where it kind of just feels natural. You just pick it up and do it. And here I just show that they're physical objects. You can just grab them and push them around and move them. And everything's intuitive. I think we're having a frame rate issues due to the connection on Zoom, but here I tried to show that when you look at the animated character and you fly around, or if you look far into the distance, it lags, as opposed to if you look down on the ground, it's much more smooth. So, there was a lot of effort put into basically making sure everything was streamlined and it didn't make you motion sick just flying around. But yeah, and then on our next slide, we have a place, or the names of all the people who created the assets and whatnot, because we imported a lot of stuff. We imported the terrain, the alien, the weapons, and the music is from a popular video game called Faster Than Light. It's had the space theme, so I liked it. And yeah.
Okay, thanks a lot. So you mentioned it worked on one of your devices, right? Whose was it?
It worked on my device. We ultimately ended up going with mostly developing on mine because it was Gen 1 and there was problems with the build pipeline between the two.
Mm-hmm.
Hi. Okay. I'm Chastity and my partners are Matt and Ryan. And
Hi.
sorry, go ahead.
Hi.
Oh, okay. Hi guys. So for our project goals, we wanted to design a variation of an escape room. And if you don't know what an escape room is, it's basically a room that has a bunch of puzzles that you need to solve in order to win or escape the room. And it's usually a physical room where you can go in and solve a bunch of puzzles with a group of friends. But for our implementation, instead of a single room, we created a whole virtual building with puzzles. And each room has a single puzzle, and when you solve it, it will unlock the door to the next room. So the puzzles increase in difficulty as you make your way throughout the building. So we thought that was pretty cool. And we'll go to the next slide. So this is our project stack. We used our personal headsets for this. Matt and Ryan have the Valve Index, and I have the Oculus Rift S. So for development work, we used Unity 2020. I used the Steam VR plugin, and we also used the Valve's Open VR plugin with Unity's XR plugin management. And we wrote some scripts in Visual Studio, which we used within the project for certain objects, game objects. And then we also used GitHub for collaboration and version control. So with that, I think we can go to the demonstration. So I'll stop sharing, and Matt, you can run the video.
All right, thank you. And hopefully we'll get sound. Can everyone see that?
Yes, the screen is
yes.
So there's going to be doors with locks, and I made those, and I made the elevators. And hopefully we'll get sound.
Yeah, I just heard that teleport.
Nice. So before checking out the puzzles, we're going to see an Easter egg where we go down into the basement. and find a little piano that I got working but never hooked up to a puzzle. Oh, but it doesn't. Huh.
That's beautiful.
I had the volume down. It's a little jank, but you know. So then here's a key that opens this door, the first simplest puzzle. And I just wanted to show off rotating it.
So here I derived from Matt's keys a combination lock. So it's a really simple puzzle. All you have to do is match up the number of sides of the object with the number on the side. So door opens when you get it correct, and I don't think it's displayed here, but the door will close back up again if the levers are moved. And here's a little...
I knew I forgot to capture
That's
something.
okay, that's okay. And I'm really proud of you for this one, Matt.
I had so much trouble with this.
Yeah.
You can see I did a little dance.
Okay, so this is the last room, and here I implemented an archery set. So we have the bow and arrow. Waiting for him to pick up the bow and arrow, and when you shoot the target, there's a balloon that inflates that you also need to pop, and that will generate the key to show up on the table right next to the door. And then you grab the key and open the door. So, and then you win.